Large language models, or LLMs, are increasingly integrated into everyday work, but this raises serious concerns about energy use, costs, and data privacy. A new research paper titled Sustainability via LLM Right-sizing, published on April 17, 2025, explores how to make smarter choices when deploying these models. The authors are Jennifer Haas from the Weizenbaum Institute and Humboldt University in Berlin, Finn Klesoschek from TU Munich and the Weizenbaum Institute, Jan Mendeling from the Weizenbaum Institute and Humboldt University, and Sebastian Pokutta from TU Berlin and the Zeus Institute Berlin. In the abstract, the researchers highlight that while big models like GPT-4o often get praised for their performance, organizations need to think more broadly about when a smaller, locally run model might be sufficient. They tested 11 different LLMs, including both proprietary and open-source ones, on 10 common workplace tasks. These tasks include summarizing texts, creating schedules, and drafting emails or proposals. To evaluate the results fairly, they used a dual-LLM framework, which means they automated the process and assessed outputs based on 10 criteria like quality, accuracy, and ethics. Their findings show that GPT-4o performs the best overall, but it comes with a much higher cost and environmental impact. Interestingly, smaller models like Gemma 3 and Phi 4 did really well on most tasks, making them viable options for situations where cost, local deployment, or privacy is a priority. The researchers used cluster analysis to group the models into 3 categories: premium all-rounders, which are the top performers, competent generalists, which handle a wide range of tasks effectively, and limited but safe performers, which might not excel everywhere but are reliable in controlled settings. This analysis underscores the trade-offs between high quality and factors like sustainability and control. One key insight is that the type of task matters a lot. For example, tasks involving concepts or ideas were challenging for most models, while tasks that involve aggregating or transforming information, like summarizing or scheduling, saw better results across the board. Moving into the introduction, the paper explains how AI is transforming business processes, from decision-making to service delivery and task automation. However, this comes with growing problems. Energy consumption from large AI models contributes significantly to carbon emissions, and relying on cloud providers raises issues with data sovereignty and privacy. Financial costs can also spiral out of control, especially for widespread use. The authors point out that local models can reduce costs dramatically, sometimes to just a fraction of a cent per token. They emphasize that sustainability in AI isn't just about the environment, it includes data ownership and operational efficiency. Despite these concerns, most AI evaluations still focus on narrow metrics like accuracy and scalability, ignoring real-world factors. This paper aims to fill that gap by asking when a smaller model is good enough for specific tasks, considering trade-offs in sustainability, cost, and sovereignty. To address their research questions, the team tested 11 LLMs on 10 typical office tasks. These included writing emails, summarizing texts, and conceptualizing ideas. They used an automated evaluation method with LLMs to ensure consistency and objectivity. The first question they tackled was whether smaller, locally deployed models can effectively handle occupational tasks. Their results suggest yes, as models like Gemma 3 and Phi 4 performed strongly in many scenarios, offering a balance of quality and efficiency. The second question focused on which models suit which tasks. Here, they found that task complexity plays a big role. For straightforward aggregation tasks, like pulling together information into a summary, even smaller models excelled. But for more conceptual work, like generating original ideas, the premium models held an edge. This highlights the need for organizations to assess tasks contextually rather than just picking the most powerful option. The paper argues for a shift away from benchmarks that only maximize performance. Instead, they advocate for sufficiency assessments that consider organizational priorities, such as cost savings or environmental impact. By doing so, businesses can deploy AI more responsibly. In their methodology, the researchers selected a diverse set of LLMs to compare cloud-based giants with lighter, open-weight alternatives. They defined the tasks to represent real-world occupational scenarios, ensuring the evaluation was practical. The dual-LLM approach for assessment involved one LLM generating outputs and another evaluating them against predefined criteria, which helped standardize results and reduce bias. Results from the study revealed clear patterns. GPT-4o was the standout, but its high resource demands make it unsustainable for routine use. In contrast, models like Phi-4 showed reliability without the hefty footprint, making them ideal for privacy-focused environments. The cluster analysis provided a visual way to understand these differences, grouping models based on their strengths and weaknesses. The authors also discuss broader implications. As regulations around AI tighten, organizations must prioritize sustainable practices. This means evaluating models not just on what they can do, but on the long-term effects of their deployment. For instance, using local models can enhance data sovereignty by keeping information on-site, reducing risks associated with cloud dependencies. Finally, the paper contributes a scalable method for evaluating AI through a sustainability lens. It offers practical guidance for businesses, suggesting that right-sizing LLMs, choosing models that match the task's needs, can lead to more ethical and efficient AI use. This approach encourages a more nuanced view of AI benchmarking, one that aligns with real-world priorities and promotes environmental responsibility.